We're making these problems just a little bit more advanced. You can see that this question here has got a sine function in it along with all the regular x's and radicals that we dealt with in the previous examples. And my question is, if this is the derivative, let's find the original function. So we've got to go think backwards. But before I do that, I am going to rewrite the derivative in terms of powers, because it's easier to use the power rule in reverse instead of radicals. So I'm going to write this as 3/4. Now that means that the original function, this must have been a cosine function. So the derivative of cos is negative sine. So that means that the antiderivative should have been negative 4 cos x. Double check in your head to make sure that works. If you take the derivative of this, do we get back to this? And I think you should say yes. Next one, we're going to take the exponent and raise it to the power of 1 and divide by that exponent. Same thing with the next one. And now that you've got a little bit of radicals under your belt, you're going to add 1 to this one right here. So that's 4/4, which is 7/4, and you're going to divide by 7/4. So simplifying this, and remember that it could be any constant, because when you take the derivative, that disappears. So g of x should have been the family of curves. We call it a family of curves because it hasn't got one particular answer, but infinite number of answers with that c, is equal to simplifying, reducing this fraction, and then flip and multiplying this one. So it's 24/7 x to the 7/4 plus c. Now moving on to another question that's a little bit more advanced than the ones we've been talking about. It's one that has a triple. We're starting with the third derivative, and I want to get all the way back to the original function. So I'm going to have to do this step by step over and over again until I get back to the original function. Before I start, I'm going to write this as a power, so that's t to the half. Then in order to get to my second derivative, I am going to raise this 1 here to 1 extra power, so add 1 and divide by the same power. Here I'm going to add 1, so I'm adding 2/2, which is to the 3/2, and divide by 3/2. So simplifying, I get 1/2 t squared minus 2/3 t to the 3/2. Again, notice that I've just flipped and multiplied the denominator. So I found the second derivative. Now let's plus c. Keep forgetting that plus c, and that's going to become very important in the next line. So now I want to find the first derivative, so I have to do this process again. If this go backwards, so this would be t cubed, the half is still there, and then I'm going to divide by 3. Minus 2/3, add 1 to this exponent, so that's 2/2. Adding 2/2 becomes 5/2, and I'm going to divide by 5/2. Plus, this is where the c is important. This has a t to the 0 really. I'm going to add 1 exponent and divide by 1. Simplifying this just a little bit, I get 1/6 t cubed minus flip and multiply, so it's 4/15 t to the 5/2 plus ct. Doing this one, and I've got to introduce another constant. I forgot that again, but I don't want to use c because it's not necessarily the same constant, so I'm going to use capital D here. So every time I take the antiderivative, I've got to remember that I have to add a constant. It's called the constant of integration. So I'm rolling up here a little bit, and maybe insert a page just so I can, oh, did that the wrong way, so I'm going to do this way. Insert the page, there we go, now I can see it all on one screen. Now I've got to do this one more time to find the actual function. So increase this by 1 and divide by 4. So instead of writing it division by 4, I'm just going to put the 4 in the denominator here, times 4. Makes my simplification just a little bit easier. 4/15 to start with, I'm going to add 1 to the exponent, so that's 7 5/2, and divide by 7 5/2, which is the same as multiply by 2 7ths. Next one, I'm going to take the c, add 1 to this exponent, so it's ct squared over 2. Here I've got to add, this is a t to the 0, so I'm going to add 1 more power to the exponent, divide by 1, and then introduce a third integration constant, and I'll call that e. So just simplifying one more time, I get 24t to the 4th minus 4 times 2 is 8. 15 times 7 is 7 times 5 is 35, so 105. T to the 7/2 plus ct squared over 2 plus dt plus e. And you could check this by taking the derivative 3 times, and you should end up with the original function.